Let me begin by stating that I'm really happy to be here. I'm grateful to Professor Panevova, Professor Hayachova, and the university, and all the people who invited me here so that I could give this presentation and two more presentations today in the evening and one on Wednesday. And I'm especially happy that I see many old friends here in the room, so thank you again. I'll start the presentation. I'll be speaking about current developments of the ETAP-3 system, but first I'll give you the main features of the ETAP as such before I proceed to new things in ETAP so that everybody could understand what it is all about. Theoretical background of the system is, as you see here, on the one hand, it's the meaning text theory by Igor Melchuk and his colleagues. And the other source, the other part of theoretical background, a very important one, is the integrated theory of linguistic description plus systemic lexicography by Professor Yuri Apresyan, who worked on this system from the very beginning. He is still with us. He does not really work on ETAP as such, but he works on this theory of systemic lexicography and many other things. So his influence is enormous. What are the options of this system? First, it's machine translation. Second, which is quite new, I will speak about that in more detail later, the tagged, syntactically tagged corpus of Russian texts. A compound, a module that generates things from the universal networking language and translates natural language text to UNL. There is synonymous paraphrasing and or quasi-synonymous paraphrasing. And there is a computer-aided language learning tool. It is a textbook. It is a computerized textbook teaching people to use lexical collocations in the language, both the native language and the foreign language. It works with Russian, English, and German. I don't think I will have time to speak about this textbook later, so I just give you more detail on that now. Machine translation runs full scale between Russian and English based on these big dictionaries. Morphological dictionaries offer around 120,000 entries, and combinatorial dictionaries are actually a subclass of morphological dictionaries. I mean the the lexicon is the subclass. It's a little bit less ambitious. It offers now 95,000 entries. This is the main part, and there were some small prototypes: Russian-German, Russian-French, Russian-Korean, Russian-Spanish, and also Arabic-English. These prototypes were made by a couple of students, and they were no more than toys. But with the exception of the last one, the Arabic-English prototype, which was developed for about 18 months by two PhD students from the Russian humanitarian university. They were Arabists, and they made quite an impressive bit of work. The major feature of ETAP are as follows. It's rule-based approach. It is still a rule-based approach, even though we are trying to link statistical elements into it, but they are no more than elements so far. It is still rule-based. The approach is quite stratificational, which means that we have strict distribution of linguistic levels. Morphology is separated from syntax, syntax separated from semantics. Another important feature, which will surely be understood here in Prague, it is that the syntactic representation is based on dependencies. It's a lexicalistic approach, by which I mean that the system heavily relies upon the lexicon, upon the dictionary. We pay very much attention to the dictionary, to the development of lexical entries, so we may call this approach lexicalistic. Another feature is that it is self-tuning in a way, which means that the number and the composition of rules working on a separate text, specifically on a separate sentence, is composed automatically depending on the sentence itself. For instance, if the sentence has certain words, these words may have specific syntactic, semantic transfer rules. These rules may be written directly in the entry, or there could be references to these rules, which means that all these rules are added into the stack of rules to be applied during text processing. This is what we call self-tuning. If such words do not appear in the sentence processed, these rules simply don't go into the stack. Another idea is that we try to reuse all our linguistic resources to a maximum degree, which means, for instance, that we do not have a Russian-English dictionary or an English-Russian dictionary or things like that. We have one Russian dictionary that, for instance, is used in machine translation when translating from Russian into English as the source dictionary, and we use the same dictionary as the target dictionary in the opposite direction of translation. It is an important feature, and I must confess that it is quite a complex and maybe not very felicitous solution, because sometimes it would be easier for us if we had different dictionaries. I wonder if I can spend a couple of seconds to tell you more about that, but still, just imagine that we have established an idiom. This idiom may be well established if it is established in the target language, because we do not have to parse it, we do not have to analyze it. But it may happen that it is impossible or hardly possible to establish such an idiom or quasi-idiom if it is in the source language. So we have to somehow to make a trade-off between our between our wish to reuse the resources to as maximum extent as possible, and the possibility to use these things that maybe are not general enough. So, to understand how it works, I give you here the general layout of translation process, or actually the translation process is here as an example. The general layout more or less remains the same in all ETAP-3 applications. we work sentence by sentence. We do not do anything that goes beyond a particular sentence. We do not even resolve anaphora, which is a shame, but still we do not have time and means to do that. So it's when we proceed with the source sentence, it is morphologically analyzed. Then we obtain a morphological structure which is syntactically parsed. When we get a syntactic structure, which is the output of the parsing stage, we go to a so-called normalization stage. We normalize our dependency tree to some extent, getting rid of some language-specific phenomena of the source text, of the source language. For instance, if we go from English, then we get rid of articles and strongly governed prepositions and things like that. It does not mean, of course, that we eliminate them altogether. There are traces of the articles, traces of prepositions, and so on, but still, in the normalization, in the normalized structure, they do not appear. The normalized structure of the source sentence is sent to the transfer mechanism, which translates the whole dependency tree, by which I understand that it translates all elements of the tree, nodes, features, and syntactic links. After the transfer, we get the normalized structure of the target text, which is a little bit expanded. For instance, in this expansion phase, we generate certain language-specific features which were absent in the normalized structure. Again, we generate strongly governed prepositions and conjunctions. We generate articles if we translate into English, and so on and so forth. Now that the target syntactic structure is ready, we proceed to syntactic synthesis or syntactic generation, after which we get a fully ready morphological target structure from which we can get a normal target sentence in the target language. So, of course, we work with a written text. Regretfully, we do not do anything with spoken text, so it is all done with a written one. A little more should be said about the dependency syntactic structure. By the way, I did not ask you how long I can talk.
Well, altogether it's 1 hour and a half with discussions.
With discussions, so 10 or something like that. So suppose we have a dependency, we have a sentence, then we can build the dependency syntactic structure for that. I think I'll just show you the structures in the presentation in order to save some time. I already mentioned about self-tuning. Some more details about that. There are general regularities exemplified here as rules that apply to large classes of words. For instance, if we speak about an agreement between a noun and an adjective, then it's a general rule. It is applied everywhere. And there are restricted scope regularities, specific rules that can only be applied to restricted classes of words or even isolated words and have limited occurrence. An example of that would be compound numerals. Even though it is quite a complicated rule to account for the structure of compound numerals, by which I mean things like 25 or 125 or something like that. But they shouldn't work everywhere on every text and on every fragment of the text. It can only work, and it need only work on compound numerals when they happen to be there. An important feature of our system is that we strive to get multiple translations of ambiguous sentences. So suppose there is a sentence like they made a general remark that something happened, which could be translated, which could be rendered as they remarked in a general way that something happened, or else they forced some officer, some general, to remark that something happened. Even though the second reading is hardly probable, still its probability is not zero. So we could be, so we could at least want to account for such interpretation. Synonymous paraphrasing is a specific thing which for some reason gains momentum now. It turns out that synonymous paraphrasing is very helpful in information retrieval tasks, in search engines. We have had a project trying to apply synonymous paraphrasing to normal text search in internet. It turned out that recall and precision even in the main degree, improves a lot if we use synonymous paraphrasing of the query addressed to the search engine. The synonymous paraphrasing is things like that. Suppose we have a source sentence. The director ordered John to write a report. We can paraphrase it using different means. Mainly, what we do is using the apparatus of lexical functions invented by Melchuk. Suppose we have a support verb, give, that can be used in this synonymous paraphrasing to yield a sentence that you see on the screen now. The director gave John an order to write a report. Or else we can use a passive transformation, which is also a means of synonymous paraphrasing of utterances. Or else we can give another lexical function. This one, give an order, is the so-called oper1, whereas receive an order is the instance of another lexical function, namely oper2. Lexical functions are very popular in ETAP. You know, or you might know, that there are different sorts of lexical functions. There are substitute LFs like synonyms, endonyms, converse terms, and derivatives. And there are collocate LFs like magen, a high degree of what is denoted by some word, oper and fung family, and things like that. In different options of ETAP, different sorts of LFs are used per se. Substitute LFs are used in synonymous paraphrasing only. It is not used in translation at all, whereas collocate LFs are used both in synonymous paraphrasing and in translation. Just to remind you what a lexical function is, I give a couple of simple examples. So if you have the magen function, which means that we would like to refer to a high degree of what is denoted by the keyword. So if these words, these nouns in the middle are keywords, disease, fog, and control, then the correct word to render the fact that the disease is a disease in a high degree is grave, whereas it would be incorrect to use the same word to render the idea that there is a fog in a high degree. Gray fog would not be acceptable, whereas you should use something like heavy fog, strict control, and so on. The Operfung family of LFs, of lexical functions, is something that connects, normally it connects verbal nouns like invitation, which can be traced in the screen, and it connects it with, it's difficult to say, it's difficult to see. So suppose somebody invites somebody else. The president invites a delegation. So if there is a verb, if there is a noun like invitation, it can be connected to the actants of this situation, to the valency of the verb invite, with the help of different verbs. For instance, somebody issues an invitation, or if John issues an invitation to Mary, then Mary receives the invitation from John. So this is the Operfung family of lexical functions. A couple of examples here. For invitation, Oper1 would be issue, while Oper2 would be receive. Oper1 of defeat would be suffer, while Oper2 of resistance would be encounter, and so on and so forth. Many of these lexical functions are used in machine translations. Perhaps I'll just skip some. I'll just skip some of the details so that we could save. So that we could save a little time. By the way, if anybody has questions, please interrupt me wherever you please, so that everything remains clear. General properties of lexical functions are, first, universality, intralinguistic idiomaticity. For instance, we can say grave disease or heavy fog, but not heavy disease or gray fog. And also the so-called cross-linguistic idiomaticity, which is very helpful in translation. For instance, if we have the Russian expression like тяжелая болезнь or густой туман, it shouldn't be rendered as heavy disease and dense fog, because values of the lexical function magn do not coincide as far as words are concerned. You cannot just translate the normal word тяжелый with heavy in order to get the translation of this word combination. General properties of these lexical functions also include their paraphrasing potentials. I already spoke about that. A couple examples. Suppose somebody respects his teachers, then we might say that he has respect for his teachers, or if he treats his teachers with respect, this would amount to the same things, or else his teachers enjoy his respect. Even though all these four sentences amount to the same idea, the wordings of them are entirely different. They can only be classified with the help of lexical functions. Practical applications use lexical functions to a very large degree. In fact, we use them to syntactically and or lexically disambiguate things in syntactic analyzers, in the parsers. We can use them, as you have already seen, to idiomatically translate set expressions, and also in sentence paraphrasing. What could be said about lexical ambiguity resolution? Let's confront two sentences, one English sentence and one Russian sentence, which are translations of each other, to draw a distinction on the one hand, and проводить различия on the other hand. Both verbs in English and in Russian are extremely ambiguous. If we speak about draw, we will be able to find that it has around 50 or maybe more, 50 senses, depending on the dictionary it is presented in. And the word проводить will have more than 10 senses in any Russian dictionary. As soon as we know that draw a distinction is a particular lexical function, and проводить различия is a particular lexical function, and we can confront them, then this ambiguity is resolved automatically. There is a very interesting application which we could refer to syntactic ambiguity resolution. Let us consider a simple example. If we say something like support of the parliament, it is a syntactically ambiguous phrase. It may either mean support by the parliament or else support given to the parliament. You understand what it is. But as soon as we have this in a sentence supplied by one of the lexical functions, the ambiguity is automatically resolved. If we say something like that the president had the support of the parliament, whereas where had is the value of the oper2 function of support, this can only mean one thing, namely support by the parliament, but never the support to the parliament. When we say he had the support of the parliament, you see that even though this phrase is ambiguous, this sentence is not. So we can write a rule saying that if a sentence has a verbal noun supplied by an oper2 function, then the genitive case or the off phrase of that can only be interpreted by the interpreted as the saying that this noun is the agent of support and not vice versa. On the other hand, well, that would be too complicated. I'll just skip that. Continuing with the features, I must show you that the dictionary that we develop is really big, by which I mean that the lexical entry is versatile, has a few features. This is a sample entry for the word chance, which has the zone of a part of speech, which has another zone for syntactic features, and we have various very complex and non-trivial syntactic features. For instance, you see here 3 syntactic features. Count is a very simple one, whereas pred2 and pred-z is not very simple. What it is, what these features mean is that if the word chance is a predicate of the sentence, which means that it can be accompanied by a copula verb, be a chance or whatever, then its subject can be an infinitive or a z clause. To do that would be a good chance. That he came was a rare chance, and something like that. It is difficult to ascribe such complex features to nouns and to other dictionary entries, so the development of the dictionary is quite a huge task. Other zones include semantic features, subcategorization frame, or else we prefer to use the word government pattern. But still we can speak about the subcategorization frame. there is a zone responsible for lexical functions, good opportunity, fair, or good chance, fair chance, and excellent chance are values of the Morgan functions of the verb, of the word chance. Opportunity is a synonym of that word. There are other instances of other lexical functions included into the sentence. And besides, just by way of example, there is a rule written in a special language developed in our group. It is called Forêt, written in French, which stands for formalism of étape, but somehow refers to forêt, which is forest for French, referring to the fact that we use trees, which make up a forest. But still, it's a specific language, which is quite user-friendly, even though you may not believe that by seeing this example. This rule is a specific dictionary rule that translates the English expression by chance into the Russian expression случайно. I'm not going to go into any details about this text. Okay, now it's high time for you to demonstrate how ETAP works before we proceed to other applications of ETAP. I hope you will not object if I give you a simple example of machine translation to be able to discuss what happens with the sentence within our system. In order to do that, I'll give you a very simple Russian sentence. Let me do that in a bigger font so that everybody could see better. I hope many of you understand without machine translation what it means. But still, let us ask ETAP to do that. This is the dependency tree. I'll speak about that later on. And then we get the translation, which is quite good. Now, let us get into the so-called log of the translation process and see what happens. This is a very good way to get acquainted with the system operation. Do it again and see the log file. So, when we get the sentence, we first morphologically analyze it. Is it possible to see what's on the screen? Yes, it is. So this sentence is composed of 6 words. Every word is first morphologically analyzed, absolutely without context. So morphological analysis is 100% context-free. So the word for моих is confronted with the morphological analyzer and the morphological dictionary to find 3 readings for moi. It is either genitive plural, or else it is accusative plural animate, or else it is prepositional case plural. So the word моих is morphologically ambiguous. Before we proceed with the parsing, we do not know what happens here. We do not know what real morphological feature string corresponds to this noun in this sentence. Let's go to the second word. It is друзей, which is again morphologically ambiguous, because друзей can be the form that corresponds either to genitive plural or else to accusative plural of the same noun друг. Again, we have a lexical morphological ambiguity here. Let's go to the next word, which is the verb зовут. And it suddenly becomes clear that in our dictionary there are two lexical entries for the verb звать. On the one hand, it is something that refers to the names of some people, and on the other hand, it is a verb whose meaning is close to that of invite. We will see that later on. The next word, happily, is not ambiguous. Ivan can only stand in one of the cases, namely the nominative case. The next word, I skip that because it would be too long to discuss. The next word is again ambiguous. Again, it is lexically ambiguous because E can either stand for a conjunction or else a particle. You might know that in Russian, the conjunction E has a homonym in the particles. Он и ухом не повел. He even didn't budge his ear, if I remain literal. So in this case, we also have an ambiguous, a lexically ambiguous word. And again, Piotr, thank God, is also unambiguous. Okay, as soon as we have morphologically analyzed the sentence, we can proceed to parse it, to get a dependency structure. First of all, we have a small we have a small intermediate module that is called Pre-Syntactic Module that ensures partial disambiguation of words from their linear context. It is a very small and actually empirically written module that, however, resolves the ambiguation of the sentence by 20% on the average. It is not much, but still it is something. In some cases, it is even better if, for instance, if we have things with very high ambiguity, like words that do not inflex in Russian. Things like metro or palto. Metro means metro, palto means overcoat, and they do not inflect. So in this case, we could expect as many as 12 readings of metro or palto, 6 cases multiplied by 2 numbers, and even more, because we have another special feature which I'm not going into details now, about which I'm not going into any details. So after this pre-syntactic module has worked, we proceed with the parser proper. And the parser proper functions according to Rodin's approach to sculpture. It takes the whole bulk, the whole rock, and then cuts off everything that is superfluous, that should not be there. So regretfully, our parser uses the approach of full or complete exhaustion of hypothesis, which means that the parser first constructs all binary hypotheses which could be used to build than dependency tree. What happens in this sentence, for instance? For this sentence of 6 words, the parser at the first stage, at the very rough stage, produced as many as 24 hypotheses. While we have a sentence of 6 words, we expect a tree to have 5 links, 6 minus 1, because you know that in a tree there is one node, which is the top of the tree, that is not linked to anything. On the contrary, every other node is linked to this top node, either directly or indirectly. So we expect 5 links. And in this case, we had 24 hypotheses formed with a factor of almost 5, which is quite big. Which means that in the course of parsing, we should get rid of 19 hypothetical links so that the 5 remaining ones could form a dependency tree. We use quite a few sophisticated filters to do that. There are filters, for instance, of repeatable, non-repeatable links. Just to give you a couple of words about what it is, suppose that we have a link corresponding to the relation between a predicate and its first first actant, the word that instantiates its first valency. Suppose there is a verb and there is a direct object of this word. He killed John, or something like that. It is impossible that a sentence can have more than one link corresponding to this relation between a verb and its first direct complement. In this case, this link is non-repeatable. So this can be used as a filter, because if at some stage of the parsing process we have already established that one of the links is linking the verb with its first complement, it is called the first completive link, then no other first completive links may appear going out from this verb. So that is one filter. There are many others. Filters of projectivity and non-projectivity. They are very intricate filters, because in our languages, in Russian, in English, in all Slavic languages, you know that there are cases of non-projective sentences. In Slavic languages, there are more non-projective sentences and links than in English, for instance. And in some cases, these non-projective trees are even obligatory. They cannot be made into. That cannot be made into projective trees, and so on and so forth. There are different ways to reduce the ambiguity during the parsing stage. There are also preference rules. These rules are also empirical, and this empirism is based on statistics. Actually, it is not based on real statistics. It is based on statistics somehow reflexed in the brain of the linguist who developed, of the linguists who developed the parser. Preference rules. Then there is a number of rules that act at an intermediate intermediate stage of parsing, called intersyntactic rules, which means that suppose we have established a bulk of syntactic links. For some reason or other, there are configurations of 3, 4, maximum 4 nodes of the tree that somehow can be confronted with other configurations. We can sometimes say that one of these configurations has much more chances to emerge in a text than the other confronting configuration, in which case this better configuration is preferred, so that other options are excluded. Okay, gradually we get rid of all these superfluous stray links and get the dependency tree. By the way, maybe while this is my most important illustration, I can show you one more thing. We have already built a tree here with the word звать in the process of parsing, but all of a sudden we found that some general regularity concerning this word does not hold true, because it so happened that in the first tree that was built, there was no mention of the second object of this word звать. And it is considered that a Russian sentence is wrong unless this second object is instantiated. So in order to assure that, we write a special rule of choice, so to say, the last resort, which simply forbids such a tree from being constructed. Then we proceed to another alternative, and then the structure is built. As soon as this is the structure, so звать, the verb, is the top node. There are two complements of звать here. The word друзей, friends, and the names Ivan and Pyotr. You understand, of course, that Ivan and Pyotr in the sentence, my friends' names are Ivan and Pyotr. Ivan and Pyotr are no subjects; they are complements. Okay, and as soon as we do that, we can start translating the tree into English. There are things that translate this tree partially. If the tree contains a fragment that is not covered by general rules, it is normally translated before other fragments are translated. It could be otherwise, of course. We could give a rough translation and then proceed to somehow improve the rough translation, but our approach is a little bit different. We try to translate all abnormal or all non-standard things earlier than standard things. Okay, so this is reflected in this tree, which is partly English. The name is here, and some of the names of syntactic relations are English, whereas other words remain Russian. And of course, we do not stop here. We go through different phases of the transfer, in the end of which we obtain a ready English tree, which had to be complemented by specific features that are absent. We sometimes resort to transformations. For instance, you see here, the first plan was to build a tree with the word "the name of my friends." Then there was a transformation that changed it into my friends' names, just to do that in a better way, and so on and so forth, until we get the fully legitimate English tree. Now, I already mentioned the fact that we are striving to get multiple translations. Now, let's look at this sentence. There is a special option to get other interpretations. We can try to resort to this option, and we will see that the first attempt failed. We obtained the same translation. Let's try again. All of a sudden, we get another reading of this sentence. I hope that you understand what underlies this translation. It is an absolutely legitimate translation, and it is possible to understand it. Because this sentence can also mean that some Ivan and Peter invite my friends somewhere. They call my friends to go somewhere or whatever. By the way, when we experimented with sentences like that, it came to us as a complete surprise. This sentence, to a human eye, is absolutely unambiguous. Why is it so? Why is it so? Because the lexical composition of the sentence is such that there are so strong inclination toward naming something, first the verb to name, then names themselves, that a normal human mind ignores such a reading. And this one, the computer does not ignore anything. If he is instructed to do something, the computer cannot ignore anything. So at least later on, it should give us possibility to obtain other readings. There was a question.
Yes. Isn't it ambiguous to humans because of topic focus articulation? Because
exactly.
And then,
of course, you are absolutely right. The probability of this other interpretation is law, exactly because of this topic focus articulation. If we had Ivan и Петр зовут моих друзей, the distribution would be just the other way around. The normal default reading would be Ivan and Petr as subjects of the invite sense of the verb, and моих друзей would be the complement. But you couldn't exclude this reading just because of the topic focus distribution, because this is also possible, even though it is not too probable. So. This is how, and of course, you understand how it all happened. If we continue with this log file, we will see that it simply chose that the parser simply chose another candidate for the top nodes, and it was звать 2 instead of звать 1. In order to fight, or in order to do something with improbable ambiguity, we developed a thing that is considered by some people quite obsolete, but it turned out to be quite helpful, the thing that we called interactive disambiguation. The idea is at least 25 years old. It was implemented in quite a few systems, even in machine translation systems in the United States. And a big proponent of this interactive disambiguation is Professor Christian Boité of the University of Grenoble. So for some reasons, we tried to develop this interactive disambiguation in our system too. So how does it work? we can refer to this disambiguation and see what happens. We are confronted with the choice. We obtain different comments and examples for different readings of the verb. And if we click on one of them, we make the parser go in the corresponding direction, so that we can obtain the structure that we need at once. So this would be the sentence that we would obtain in this case. What had to be done to ensure that? We had to go through the dictionary, find words that had many readings, at least two readings, in which case we even had to resort to words that have different readings, not in the initial names, not in the lemmas, but also in word forms. Suppose there is a word form that somehow intersects with the other form in a part of the paradigm. Let's take the Russian numeral 3, which intersects with the imperative of the verb тереть, 3, in which case we had to include comments and example both into the numeral and into the word тереть, and so on and so forth. So this is about machine translation. Now I would like I would like you to see another option of our ETAP multipurpose linguistic processor, namely the component that enables us to construct a syntactically tagged corpus of Russian. A few words about this syntactically tagged corpus. It is called Syntagrus, which with clear associations what it is. It's syn, syntax, tag for tagged, and Rus for Russian. But on the other hand, Syntagrus refers to syntactic rules, which we call syntagms. So this is again a multi-layer name. Our corpus is not big. It consists of 500,000 words now, which amounts to 35,000 sentences. They are constructed in the following way. First, the ETAP parser, the same parser that is used in the machine translation option, builds a dependency tree for this sentence, whereupon every sentence is looked at by an expert linguist. And the dependency tree is manually corrected by this expert, which allows us to obtain a rather high quality corpus. Let me show you how it is done. There is a special device called structure editor. Let me show you how it works and what can be done when building the corpus. Let us find some text. Suppose there is a text. This is text information, and this is the sentence by sentence tagging of the text. Let's see some tagging. What will you have here? On the one hand, you will have the same dependency tree that you saw in the translation On the other hand, you may see many other things because all this corpus is built under XML. The source looks like that. It's a normal XML with features that are ascribed to words. So it allows easy computation, which helps us to use to stage many statistical experiments with it, because the corpus is used as gold standard for parsing. So we can train our parser on the corpus as a gold standard. We can also use this parser. On the one hand, we can train our parser on this gold standard. On the other hand, we can gather statistics on this corpus so that influence the parser. So on the one hand, we can assess the parser performance. On the other hand, we can influence it, adding statistical elements to its work, improving it after the performance of the rules. Okay, now what can you see here? On the one hand, it was, as I said, a tree. This view shows you the so-called integrated description, and we can click on anything to see what refers to a particular word. This is the word form. This is the lemma. This is the name in the combinatorial dictionary, which can be different from the lemma name because our corpus is not disambiguated for word senses. Actually, it is disambiguated, but the corpus, which can be seen on the website, is not lexically disambiguated. You can only see words and links that connect these words. So just imagine that. One more thing. There is a special trick called complex debugging. In this case, we were not successful in the complex debugging of this tree. I can even guess what happened. In this case, we had a sentence in which the nominal part of the predicate precedes the copula. Готовы были занимать. This is a somewhat unexpected word order in Russia. Были готовы занимать is the more acceptable, more normal word order. So what we did was as follows. We had a pre-syntactic rule that changed the order of these words within the sentence because we were oriented at machine translation. And it would be absolutely irrelevant for us what internal structure we obtain. It is not so for the corpus, because the corpus should be okay. In this case, this complex debug could not produce good results because it should take account of this particular decision, which was not yet done. So that was in this case, it was a failure with the complex debugging. I hope this would not be failed. Yeah, it failed in a way, but the performance was okay. But it showed us that there was some mistake in the presentation. So for some reason or other, we obtained this syntactic link as being quasi-agentive, which might be wrong for some reason or other. Maybe because the entry for this word razminka, which is training, does not hold the corresponding string in the government pattern. Let's see what happens. Let's open this dictionary. Let's open this word razminka. And we will see what happens. There are references to the fact that what can make a razminka or training, that it can only be a man, a human, or some institution. And here, there is razminka krizisa, training of a crisis. Crisis tried to train itself. Of course, it's a metaphor. In which case, we are confronted with a very difficult trade-off. Whether we should account for all metaphors and allow them to appear in all sentences, or else we should restrict metaphoric uses from appearing, in which case we risk obtaining bad structures for metaphoric uses. This is, again, a very complicated case, complicated trade-off, which we have to take account of. Our recent approach to it is that actually we make metaphors appear in the text, even at the expense of loosening the restrictions. So in this case, what could be done? We could either leave this as is, disregarding this error, or else improve something. Either decide this is a different structure, or else decide that this is a correct structure, and then we might choose to improve the dictionary. So you see, this tagged corpus can also be used as a test bed for improving the dictionary and the system as a whole, even at this low level of particular observations. Okay, as I said, this text, this corpus is composed of 35,000 sentences, and it grows every year by 6,000 sentences. It is not many, but we would like the corpus be really high quality. Otherwise, if we do not do that, if we allow more automatic processing, then the corpus would not be as good as we want it to be. Okay, so that was the second important thing in the ETAP development, Syntagrus and ways to develop it. The third one, and I'm more or less approaching the end of my presentation, is the thing connected with UNL, or Universal Networking Language. I wonder if anybody of you heard about UNL. No? Oh, you have. Some of you have. Yeah. Yeah. Exactly. It was invented by Professor Uchida of the United Nations University in Tokyo, some 15, maybe 12 years ago, as an interlingua for semantic representations. And for some complex of reasons, both scientific and personal, Igor Boguslavsky tried to include UNL into our into our inventory of applications. Let me return to my presentation and show you what the Universal Networking Language Architecture could look like. As I said, it was meant to work as an interlingua in machine translation or whatever. Suppose that this is the internet shown. There are people all over the world trying to understand something. There is the UNL system. So the interlingua, the UNL works as an interlingua so that from every language, natural language, to this universal networking language, there could be built a system of translation. There are two terms that are used in connection with UNL. It is enconversion and deconversion. Enconversion is translation into UNL, and deconversion is translation from UNL into natural language. The UNL language of meaning representation is built on the basis of UNL graphs. The amount of sense rendered by a UNL graph more or less corresponds to a natural language sentence. So if we have text in a natural language, and we want to translate it into UNL, that means that we should build a number of graphs, each of which corresponds to a natural language sentence. These are two empty architectures. I'm not going to dwell into details because I already mentioned that. You can translate it via transfer, or you can translate it by interlingua, translating once into interlingua and then from interlingua. Transfer is language specific, interlingua is not. Semantic units of universal networking language are so-called universal words that are designed on the basis of natural language. In this case, it is based on English, which can be semantically modified. They are really semantically modified because, as you know, English words, as words of any natural language, are ambiguous. In the UNL, the whole thing is deprived of any ambiguity, so that, for instance, these are three. So what is the strategy? Actually, lexical meanings of the natural language are either coincide with the meaning of an unambiguous natural language word, or else it coincides with one of the senses of an unambiguous word, or else a lexical meaning that should be entered into UNL does not coincide with any of the lexical meanings of the given language, in our case, English. What could that be? One of the things is that we have to disambiguate natural word senses. If we take an English word coach, example used by Uchida, it may either mean a bus or a trainer, or the verb to train, or the verb to drill. In this case, UNL will have 4 universal words with the same title, coach, and delimiters that can be done in a relatively free way. It can be said that it is a synonym of bus, and on a broader scale that it belongs to transport. Then it can be said that it is a person, and the object of which somebody who coaches somebody is somebody who is coached by somebody is a sportsman, or else the verb, which is represented here by the delimiter do, or else another verb, only differing by objects of this verb. It can be sportsman, in which case it would correspond to the English verb train, or else a student, in which case it would correspond to the English verb to drill. You may, of course, see at once that these are very rough interpretations of English words and very rough disambiguations. But then universal networking language is a system that only strives to a minimum degree of granularity. Okay? So, suppose that the English language does not have certain senses that are offered by other languages. Let's take some part of a Russian lexicon, verbs of motion that are oriented to the finite point, прибежать, прилететь, приплыть, or приползти. In this case, universal networking language will become richer by 4 words. It would become with delimiters, stating the method of coming: running, playing, swimming, or crawling. As you see, this granularity is also quite low because, for instance, прилететь can not only be by plane, but also can refer to a bird which does not fly by plane, or if it does, it would be the same meaning as for the man. Or else, new universal words would be formed if there are words that do not fully comply with English translations of them. Suppose the Russian word жениться is an equivalent to marry, but a rough equivalent, because жениться can only be said of a man, whereas there is another expression, выходить замуж, which can only be said of a woman. And respectively, since UNL must work for, hypothetically, for any language of the world, including Russian, then we should obtain universal words with this meaning. Marry with the saying that agent of that is man, and marry with saying that agent of that is woman. So that this is the UNL module of our system. It is actually implemented. In part, I wonder if I should demonstrate how it works, but perhaps not, as my time has almost run out. But I must tell you that it works more or less in the same way as machine translation, even though so far the results are not spectacular. What is good, however, about the UNL is that we were able to develop quite a big dictionary of UNL, of universal words, and we have elaborated a zone of translating English words into UNL. And this is what this is perhaps what I can show you. Let's take some English words. Anything. I'll just picked up a few words, and you see that beside the area that is responsible for English to Russian translation, there is an area that is responsible for English to UNL translation, in which case we have here 2 readings of forest as a noun. It is either land that is covered with trees and shrubs, or else the trees and other plants in a large, densely wooded area. So land, or else the trees itself. Most of these readings are taken from WordNet. So it was collected more or less with a large share of automatic work. While we hope that these things will be disambiguated automatically, we offer possibility for ambiguous, for interactive disambiguation, even though in some cases it would be very difficult to disambiguate them. In reality, suppose somebody saw that he saw a forest, and I wonder, let's stage a very tiny experiment. I say, John saw a forest yesterday. Who would say that he saw land that is covered with trees and shrubs? Or else, who would say that he saw the trees and other plants in a large, densely wooded area? I wouldn't venture to do that. So, as we saw, UNL is an experimental language that has some semantic interest, because as far as semantic processing is concerned, it offers some good things like semantic graphs with scopes and everything like that. I think that my time has really run out, so I would like to finish this talk by thanking you for listening.
Thank you very much.
I have one very formal question. How do you cope with accents, ударения? Do you simply discriminate them or not?
Actually, we disregard accents. We work with written texts, unaccented texts. Regretfully, because sometimes it is necessary to have accents, especially in cases when they differentiate between readings.
How do you define the language-specific features with the other languages than Russian? Is it compared to Russian, or how do you decide what you eliminate during the normalization?
Well, of course, we did not work with many languages. Our research is not typological, so we only worked with the languages that were listed here. Still, we understand that when we compare Slavic languages and English, for instance, or German, then we can see that there are things that are language specific for Germanic languages, like articles, and language specific features of Slavic languages. By the way, some of the features are considered to be ethno or language specific in all languages. For instance, if we speak about strongly governed prepositions or conjunctions. Let's compare two things, like давление зависит от температуры and pressure depends on temperature. От and on are language-specific instantiations of these units. You cannot just say if we left these prepositions in the sentence, we wouldn't simply be able to translate correctly such items, because it is impossible to translate ought as on. It is not a default translation, and it would be impossible or absolutely strange to write rules that would translate ought as on within any context. We simply get rid of them and then produce them as language-specific items in the target text. Is that, have I answered your questions?
Well, prepositions are obvious. I'm asking because I'm working with tectogrammatical annotation of an English corpus. Yeah. And for me, it's extremely difficult to decide whether something in English is language-specific for English to English because it isn't in Czech or.
For instance.
Oh well, cleft sentences.
Oh, you mean syntactic phenomena?
Yeah.
Well, syntactic phenomena are language specific, of course, but most of these specific phenomena, we do not. What do we do about that? Of course, it's a very important issue in translation. Suppose we have an irregular endemic syntactic phenomena. I can give you such a syntactic phenomena in Russian. It would be approximative quantitative constructions. I don't know whether they exist in Czech. Он съел яблок 5. He ate apples 5. He ate approximately 5 apples. Does this exist in Czech? It does. Okay, so it's endemic. Of course, we leave this phenomenon in the dependency structure. But then we had rules to supply the English structure for, to substitute the corresponding English structure for this phenomena. We will introduce some additional word like approximately or whatever, but it is of course remained in the Russian structure. We wouldn't be able to somehow get rid of it. Otherwise, what we would obtain would not be a Russian structure at all. But of course, for practical reasons, we could do even that. We could introduce such a thing as приблизительно, approximately, in Russians, doing such a transformation within the language. So my personal opinion is that I wouldn't do that. I would leave it as is because it's a specific phenomena. The same would refer to cleft sentences in English. Which ones do you refer to? What kind of cleft sentences do you mean now?
It was yesterday John broke the window or something.
Yeah, I see. Yeah, okay.
At the beginning of your talk, you talk about two types of dictionaries. The second one was combinatorial dictionary.
Combinatorial.
I wonder what
oh
it
yeah,
is.
I'm sorry. I missed that point. Actually, I said at the beginning that our work is based on the meaning text theory by Melchuk and Aprisian. And in the meaning text theory, there is a specific type of dictionary called explanatory combinatorial dictionary. It is explanatory because it has definitions, and it is combinatorial because it lists many combinations of words, mainly with lexical functions on the one hand, and on the other hand, in the government pattern, on subcategorization frame, saying that some word, some verb requires, I don't know, preposition or conjunction or infinitive or whatever. We do not have, regretfully, we do not have definitions in our dictionary, but we do have government patterns and lexical functions. So from the word combinatorial and explanatory, we only remain one thing, combinatorial, that presents the combinatorial facilities of the language. And the other dictionary was morphological. There is only a morphological dictionary which has all data necessary for morphological analysis plus a default translation.
May I have a question too? Yeah. It is connected with the question of Jarka. How the lexical functions are encoded in the dictionary for ETAP. I mean, for instance, if тяжелый is magen for болезнь, for чемодан, but not for tuman, how it is reflected in the entry in the dictionary?
Simply in the word болезнь, it is written that magen of болезнь is тяжелый. For чемодан, it would not be written because it's the normal reading. It's not lexical functional reading. Perhaps, I don't know. Maybe it is, but тяжелый чемодан is the one that is difficult to tackle, so to say. But simply by finding these, we have a list of functions. We find correlates for these lexical functions in the dictionary, and then we code them.
I understood that casually with chemodan is normal, and it is not lexical function.
Well, it depends. Maybe yeah, I don't know.
So, Nikki, you cancel your question?
Right.
So, excuse me that I will stop this interesting discussion.
Well,
and
I'm
once
sorry to
more,
have
many
spent
thanks for your presentation. It was very rich and very nice, and we are looking forward to the other.
Thank you very much.
Thank you.